Ladies and gentlemen, good afternoon. Thank you for CoinGeek's invitation, for allowing me to introduce a little bit about us and about our full custom design methodology for the ASIC miners behind. And first of all, please kindly allow me to salute to the 10th anniversary of Bitcoin and a salute to the genius geek, the Satoshi Nakamoto. Yeah. It's 10 years ago when he issued his peer-to-peer electronic payment system. After 10 years, everybody understand here, this is really opening up a new era for our humankind. And profoundly, maybe after 5, 10, 15 years, it will be profoundly change the way we work together. So it's really genius. And as Terrace shared with us this morning, this is a price chart, Bitcoin chart, and looks like starting December 17 is a peak, is $19,835. That's a peak of Bitcoin in the history in December 17. And starting from that, continuously dropping down, and especially in the last 3 weeks, in total from like $6,500 per Bitcoin to, at the moment, it's about like 3,700. So make a lot of people chaos, despair, and but a lot of real deep believers like Bob said, this is a very good chance to invest more money in this. Yeah. So this chart, more or less, similar to Terrace chart. I borrowed from the right-hand side is Gartner, and here side is from Chinese, the similar cycles. I don't want to repeat what Terrace said. So basically, according to Gartner's 18 years of hype cycle for emerging technologies, blockchain, it's right now at the downward side as this side. So basically, according to the hype cycle, it takes another 5, 10 years really become mature and widespread utility for various applications in the whole societies. And so it's, from my personal perspective, from us as a miner design perspective, it's a really, really right time for deep believers to invest our time and energy and technology to do this. And so, as always, there's a lot of debates regarding POW and the POS. Some people said POS is environmentally friendly, consume less energies, and from mathematics perspective, it theoretically provides the soup secure. But my personal thinking is POW after 10 years of development is really provide provable secure system. Although, yes, at the moment people are still working on, just like Chen and Jimmy mentioned, still working on the scalabilities and also the efficiencies and instant confirmation of the transactions. For this one, all the community ecosystem are working on this. I think it's definitely in the next 2 or 3 years, it can improve. So after all the comparisons, POW is still most robust and most secure, probably proved by the last 10 years. Most secure consensus protocols. Of course, basically, blockchain system, I don't want to repeat, everybody here is an expert. So basically, it's a consensus protocol how to realize in scalable and secure ways on the mutual protocol consensus. Of course, all the time, whenever there's things, because this is a really decentralized, democratic, democracy, the experimentations. So with the time going on, people have different thinking. So this is why we're, especially in the last a couple of months, there's so many heated debates regarding the Bitcoin and Bitcoin Cash. And also, some people said we have to stay true with our original aspirations when Satoshi Nakamoto designed the Bitcoins. And some other guys think, okay, with the time going on, the application is going there, all kinds of new demands, new technical requirements needed. So we have to evolution the ways instead of also some other gentlemen said, okay, we have to stay with what Satoshi Nakamoto designed and original, stay where we are, why we started. And so this is I just put it this way: say rationalism versus evolutionism, and also the hard fork and the soft fork. I don't want to elaborate more. Yeah. And so as Terrace introduced also, this is a brief history of Bitcoin. In the January 3rd, the Satoshi mined out the Genesis block, and starting from then, he used, so people use CPU to mine out, and very quickly shifted to use GPU to find more efficient ways in 2010. And then very quickly shift to the FPGA. And in year 2013, started, later I will elaborate more, started the ASIC mine designers, and it's a really fantastic stories I will share with everybody here today. And regarding ASIC miners, right now this is our Watts Miner M10, the latest version based on the 60 nanometer process. And this is a normal Watts miners, and of course, a lot of persons in the last couple of years trying to explore whether it's a feasible way, technically, economically feasible way to use hydro miners. And of course, it's not just the miner itself, but also the mining farm, engineering cost, overall investment. By the end of the day, we are talking about the payback period and also the overall the technical cycle times for that one. And of course, some people also exploring the possibility of use the traditional way of server rig. And regarding mining farm, the mainstream, of course, is just like data center, high performance data centers. And in the last 1 year, we can see more and more people adopt the container farms. And recently also more and more people use fluid coolant systems to combine together the container. The container can provide more easier to mobilize around, and also provides one container, 20-feet container can accommodate more than 200 units of miners, and 40 feet from 500 to 600 servers. And especially in southwest China, there is hydropower. So hydropower have wet season and dry season. In dry season, the power supply is dropped pretty much. Then they have to move around the rig to the coal-fired power plant, which can supply the stable power supply in the winter times. And so for this one, but there is also some people develop the factory levels fluid coolant systems, but it need a lot of engineering cost. And so things are still going on. There's so between these two options, still take a while to depend on each location's specific power, electricity, the cost of engineering, cost of constructions, etc. And this morning, I have a chat with one gentleman here. They are trying to standardize the engineering of the farm, standardize the electricities and the constructions, and the standardization of the daily operation and maintenance. This is really, from our perspective, this is really the trend of the mining industries in the future. Whenever you provide standardized, if the customer, he say, hey, Jordan, I have 100 million US dollars, so give me a solutions. Maybe we give them most efficient mining farm solutions with the most cost-effective and the most highest or suitable quality of mining facility, and also provide them wallet solutions, cold wallet or hot wallet solutions. That could be the way for serving the customers better. Because when the old money come in, recently a lot of around the world, old money, especially those very big giants like Goldman Sachs, Morgan Stanley's, they are really putting pretty much resources into study what kind of financial resources put into their customers' portfolio to manage it. So for our mining industry itself, we need to think about what's the best solution we can provide to our future customers, not just the individual miners, etc. And of course, there's a handoff of news regarding in the North European side, the explore the undersea farm. But I don't think this is feasible at the moment, because you have to have very strong engineering capability to do the sea scanning, make sure you under the sea you don't have the sea surge waves, and you also need to build the foundation and make sure that it was fixed, don't moved by the waves, and also make sure the connection of the cable, the data cable and the power cables well furbished, and also the cooling systems, etc. It's at the current stage of Bitcoin mining, I think this is technically not so competitive. I have to say, not so competitive, not safe, not feasible. Yeah. And that's then next for the main part. The major power behind the ASIC miners is the ASICs for hash board. And I would like to share a little bit more regarding history and our projection for future in next 3 to 5 years time. What could be the time, the horizon? What will be the come in the horizon? Of course, the first in the April 2013, based on the 130 nanometer process, one Chinese company named FlightCat launched the first ASIC-based miners. So as you can see, that time is a very small, only like 10 gig hash per second, but very terribly high power consumptions. But that's the first one, already better than the FPGA. Yeah. So this is Genesis ASIC miners. Of course, there's also Avalon and other guys, but here I only put the main technical note. In December 13, the Bitmain launched its first ASIC miners based on the 55 nanometer process, and it's about 180 gigahash per second, and the power is 1,800 watt per terahash. Then they are continuously working on that one, so rely on the process node progressive from 55 to 28, launched the 440 gigahash per second and 800 watt. And their final project, the product based on 28 nano is this one. Of course, in between there's another product, the 450. I don't want to list it here. It's just the same technical node. And for this 28 nanometer node, which our company CEO and CTO, Dr. Yang, launched in the April, and the mass production in July of 2017. This is ACME of the 28 nano miners. the hash rate is 12 terahash, and power consumption is 180 watt. So this is, if we only compare on the technical node itself, this is the best technical spec for this one. Of course, before that time, Bitmain in September 2016, it launched its S9 based on the TSMC 16 nanometers. It's around like 100 watt per terahash and 13.5. That's the initial product. So then time flies. In the September this year, MicroBT, here I want to introduce MicroBT is our company brand, and What's Mine is our machine brand, because in the future, under the MicroBT, not just the cryptocurrency miner, maybe also the AI and others. We launched based on the TSMC 60 nanometers, and we realized the 33 terahash and 65 watt per terahash power consumptions. And I can be proudly announce that this is the product which you can really test in your mining fund in the market at the moment. Yeah. And of course, you may heard a lot of people are like 2 Japanese players, a handful of Chinese players, the working on the 7 nanometer process. And there's also launches in the market, like a couple of them, but the majority of them are the actual performance is above 80 watt per terahertz. And like half a year ago, when Intel approached us, said, okay, they feel very secret, okay, I share with you, want to sell the chip to you. But actually, they are also based on the 7 nanometers and only 75 watt per terahash. And so anyway, from TSMC, 7 nanometer process itself, it still take a while to ramp up the yield, ramp up the maturity of the technology. So in the short time being, we think our product, I will introduce a little bit in more details later on, still the best product in the market, even compete with the 7% nano, even those friends are utilizing ASIC boost technology to do that. And basically next year, sometime next year, the 7 nanometer process will become mature. Not process itself, but also for the ASIC chip itself. So it can be further downward transfer from saving depending on each company's designing capacity. So can save lower the power consumption from our current 60 nano to like 30 or 50%. So you just do the calculation yourself, and also for the hash rate can up 30 to 50%. So basically, sometimes next year, 7 nanometer product, or some companies 10 nanometer, whatever, can be launched in the market with 30 to 50% of power reduction and 30 to 50% of hash computation powers capacities. And from the foundry perspective, next year they will start to ramp up the production for the 5 nanometers. And but the 5 nanometer will get mature in the 2020, and it can be further down from 7 nanometers from 20 to 40% on the power consumptions. And the computation power hash rate can be improved also further, 20 to 40%, depending on each ASIC mine designer's capacities. And of course, at the same time, as you may see from the media coverage, see the cost for design the chip based on the 7 nanometer and finally it's pretty expensive. It could be easily over like $50 million US per designs. And in the manufacturing process, 5 nanometer or 4 nanometer is the end of FinFET process. And starting from the 3 nanometer is a GA, gate-all-around FET process, which can further lower the power consumptions. And according to foundry companies' technology roadmap, sometimes in 2023 or 2024, the technology node will progress to the end of the Moore's law, which is 1 nanometers. And if that 1 nanometer process get mature, and the ASIC miner based on that, first of all, we don't think about the design cost for the ASIC chips, but the power itself can lower to single digit. So at the moment, you can imagine if it's 1 nanometers, power consumption is the 1 digit watt. So the guys who are promoting POS will surrender. Say, okay, we really provide the environmentally friendly, energy-saving solutions. So this is as I said a moment ago regarding. So right now, people are playing around on these 3 technology node in the next 2 years. So this is 7 nano already 20th generation, and 5 nanos is 21 generations. So imagine this is a pretty expensive process. For the investment for the 7 nanometer, one production line like 40,000 wafers per month or 50,000 wafers we are talking about over $10 billion US investment. So think about we design the chip based on that, how much the cost we have to input. So anyway, in the long run, it's dynamic. It's really depending on the technical performance and also the cost of developing the chips. So on that one. And so come out our what's minus self. We have a technical vision on the street objective. We want to become the best provider of the cryptocurrency miners with continuous innovations. This is exactly what we have been doing and will be doing the past. And also, at this time, we think we are the member of the Bitcoin community and the Bitcoin ecosystem. And we want to be a responsible and reliable and trustable members. And we want to become a value contributor, not value destructors. So want to play with the developers and also the application merchants and so provide what we can to facilitate the healthy development of whole ecosystems. And this is where we, MicroBT, what's minus stand. We have been pioneering and starting recently we are trying to promoting the full custom methodology design for ASIC ICs and really look inside, use our craftsmanship spirit to harness, improve the ASIC technical specs and economic performance as much as possible to the extreme. So look inside and enable our partners in the communities for your better futures. Yeah. So this is our strict objective. And so what's the full custom design? This is a traditional way of the chip designs. First of all, utilize foundry standard cells and use a Verilog to write up the ITO code. Then do the logic synthesis and work out the net list and do the auto placement and clock tree synthesis and auto route. And then finally generate the GDS and provide the GDS file to the foundry factory to produce the ASICs. And what we have been doing, what our Dr. Yang are doing is we nearly don't use foundry standard cells. We do all the cells ourselves. Because why? Because foundry cells, they have to cater to the needs of widespread customers, from computers, from mobile phones, from all kinds of applications. So they have to consider about the university. And we focus on our SHA-256, the algorithm required protocols, and customize nearly 100% cells, all ourselves. And based on that, cells is just like a building brick for construct the buildings. And also we do the net list codings. So here I heard some people are the expert on the software side. So if you use assembly language to do the coding, or use the C or C+ languages to do the softwares. So think about the efficiency difference between assembly language and the C languages. So our manual net list coding itself also, later I will show you the data, much better than use the EDA tools, do the logic synthesis. And during the manual placement, we also consolidate the clock tree synthesis together. When our engineers to do the manual placement or logic designs, we also put the physical implementation into the mind. So basically the engineer itself, when they do the design, they are also just like a computer doing the assembly language. So what could be not only the logic side, but also on the physical implementation side? What's the best way to do that? Our first tries, it's about like 8 years ago. Use full custom design on a RFID tag chip. As you can see, if you use auto placement routing, peak power conversion is 8 micron amp, and the gate count is 8,000, and we utilize manual net list codings. As you can see, reduce the powers pretty much. So overall efficiency and also the gate counts nearly half. So overall optimizing ratio is nearly 12 times. And further tries on 28 chips, which is our the M3. As you can see, the M3 is at the peak of the 28 nano chips in the market. Of course, at the moment, it's already outdated at current market situations. So anyway, in the process node, it's provided way better performance over the traditional way of design. And 60 nanos, this is another alchemy point for the chip designs. This is a normal working mode, 65, and the cost is only about like $30. So whenever, so as you can see, at the moment, BTC price is about $3,700. And so at the moment, who is provided the highest hash power and the lowest power consumptions and the lowest cost, who can survive in the market and who can bring the best value to the communities. This is our latest Bitcoin miners, which is launched in September. Normal working mode, 65 and 33 terahash rate, and low power mode, 57 and 28. This is purely based on the chip. We are not using the ASIC boost. And just for the side example, recently we launched the one chip, the DCR chip, which is another crypto. So I don't want to talk too much. This is basically our power is 46 terahash and 48 terahash. The current, before our launch, the market, the highest power consumption is 150 watt per terahash, and the hash rate is only 11.5. So we are improving another 10 times over the before we launch the original designs. So why full custom design so powerful? And we don't want to boast ourselves. We want to promote in the industries. Use everybody like Square mining your peoples to adopt this kind of methodology to extend the lifetime of the Moore's laws. Frank speaking, after 5 years, when process node approaching 1 nanometers, we are talking about N10 levels. So N10 levels means quantum effect. So basically, it's a physical limit of the foundry process. So how we to get more potential from the chip design itself? The full custom design is one of the ways to generate more values to the miners and also for our Bitcoin communities. Like cell itself, we do our manual cells, customize all cell ourselves, nearly all, 100%. So power consumptions can be as low as 1/3 of automatic, the user EDA tools. Area can shrink from 5% to 1/3 of the original design. Speed can improve a little bit. And manual placement can utilize, use normal EDA tools. The cell utilizing only about like 60, 70%. And our M10 X- utilization is 97%. The project, what we are going right now, we are talking about 999 utilizations. So this methodology itself is also progressing itself. So we utilize so-called craftsmanship to work to the extreme, to harness the potentials, to harvest the potential, to help to extend the life of the Moore's laws. And the manual placement and also the power can reduce a little bit, up to like 20%. The speed can increase. And clock trees, especially clock tree can use the rising edge and managing the synchronization, not using synchronized clock trees, but synchronize the clock trees to reduce the leakage power and overall power consumptions. And of course, the netlist, just like we use our own, software side of the assembly language, we use the chip design side, yeah. So basically, we think and firmly think the full custom will be the trend for the chip design, and we would like to share with friends here, friends in the industry to jointly working on to improve and create a value for the industries. So by the end of the day, I want to emphasize we want to become the best provider of critical miners. And we want to become responsible, reliable, and trustable partners in the industries and a value contributor, not the destructors. And we want to pioneering and promoting and spreading full custom design to share with our fellow friends to jointly improve the ASIC design and to extend the Moore's law and enable better future for the industries. Thank you.